All right, these are the proof review questions, the proof booklet that we're using to review for the quiz. So the first one here is proof number 5. I have to zoom out so we can see the whole thing though. Okay. So they're giving us 2 midpoints. So again, what we did in class is we listed our givens first. They're going in a little bit different order. Whenever they need to use one, that's when they put a given in there. So theirs are a little bit out of order. That's okay. So we have 2 givens here. So we know A is the midpoint of Tn. So that's given. And then we know A is the midpoint of HK. That's our other given. So we have 2 givens here. Okay, for us then, we're just going to go down our list and see what we have. The first thing on the list that we want to look for are vertical angles, and we do have vertical angles. Okay, these are going to be the vertical angles here. So that's angle TAH. Right, and that's going to be congruent to angle KAN. Okay, and that is your vertical angle theorem, right? Your vertical angle theorem says vertical angles are congruent. So the vertical angles are congruent. Okay, next on the list is shared sides. We don't have any shared sides. We have a shared point. Point A is part of both triangles, but we don't have a side that's part of both triangles. So we move to the next one. Next one is midpoint. We do have a midpoint. In fact, we have 2 midpoints. Okay, the first one says that A is the midpoint of Tn. So here's Tn. If A is the midpoint of Tn, that means it's going to split Tn into 2 equal pieces. Okay, so we have TA is congruent to Na. That's the definition of a midpoint. Okay, midpoint splits it in half. If you have a segment here that's 12 units long and we split it in half, each of these is going to be 6 and 6. So everything on the right is going to be congruent to everything on the left. So here A was the midpoint of Tn, so everything to the left is congruent to everything to the right. Okay. We also know A is the midpoint of HK, so here's HK. A is the midpoint of HK, so we know HA is going to be congruent to KA. KA. Okay, and again, that's definition of a midpoint. We have 2 midpoints here, so we're going to use definition of midpoint twice. And we want to fill in our diagram as we go along. So the last step shows us that the triangles are congruent. We have 5 ways to show triangles congruent. Side, 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 angle, 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 side, and hypotenuse leg. Here, if we look at this one, we have 2 pair of sides that are congruent and 1 pair of angles. And that angle is between the 2 pair of sides. So we're going to have side, angle, side. So side, angle, side postulate is going to tell us that the triangles are congruent, which is what we're trying to prove. The second one then, this is very similar. So we have 3 givens. Okay, 3 givens for this one. AC is congruent to CE is given. AB is congruent to ED is given. Okay, let's fill those in. So AC is congruent to CE, and AB is congruent to ED. Okay, the third thing we have is C is the midpoint of BD. Okay, that's also given. Okay. So we go down our list. So we have vertical angles? No. Do we have a shared side? No. Do we have a midpoint? Yes. So we use our midpoint. C is the midpoint of BD. So if C is the midpoint, if it's in the middle, that means CD and BC are going to be congruent. So we can say BC is congruent to DC. That's, again, just like the first one, the definition of a midpoint. We now have 3 pair of congruent sides. 1, 2, 3. 1, 2, 3. So we use side, side, side to say that our 2 triangles are congruent. Once we have 3 pair of sides that are congruent, we know the triangles are congruent by side, side, side. We go down. So this one here, proof number 1. Okay, it's giving us two things that are given. So we know pH is parallel to Ne. That's given. Okay, and then we know pH is congruent to Ne. Okay, that's also given. So we fill those in. Right, after the given, we look at our list for things we're trying to show that triangles are congruent. So we need to use one of the 5 postulates to say triangles are congruent. In order to do that, we need 3 pieces of information of some kind. So we're given one congruent statement. We need to find 2 more. So we look at our list. We have vertical angles. So we can use the vertical angle theorem. So the 2 vertical angles here are POH, angle POH. So that's going to be congruent to angle EON or NOE. Again, O is the vertex, so it's got to be in the middle. Okay. So there's our vertical angles. We keep going now. Shared sides, we don't have any. Midpoint, we don't have any. Bisector, we don't have any. Parallel lines, we do have parallel lines. If we have parallel lines, we're looking for alternate interior angles. Okay, so here's a transversal. Alternate interior would be angle P is congruent to angle E. Those are alternate interior, and they're congruent because the lines are parallel. The alternate interior angle theorem tells us if the lines are parallel, alternate interior angles are congruent. We could have also used this as our transversal and said angle H was congruent to angle N. That would have been fine too. Now we have 2 pair of angles, 1 pair of sides. The sides not between, so 2 pair of angles, 1 pair of sides. That means we're going to have angle side angle or angle angle side. Okay, if I erase all this though, we had these 2 congruent. We had vertical angles and we had alternate interior angles. So if the side was here, it'd be angle side angle. But since the side is not included, it's not between the 2 pair of sides, we have angle angle side. So the angle angle side postulate would tell us that the triangles are congruent. Sixth one here, we have 2 givens. Rn is perpendicular to AG. And we have A is the midpoint of Rn. Okay. So if we look at our list, first thing on the list is vertical angles. We don't have any. Second thing on the list is shared sides. We do have a shared side right here. AG is part of both triangles, so we can say AG is congruent to AG by the reflexive property. Okay. We can keep going. Midpoint. We do have a midpoint. A is the midpoint of Rn. So if A is the midpoint of Rn, that means Ra is going to be congruent to Na. So we have to do that below here because we have a given here. So we got to do it below it. So since A is the midpoint of Rn, we know that Ra is congruent to Na. Right? Because the midpoint splits it in half. Right? So if A is the midpoint of Rn, these 2 are equal. Okay, and that's the definition of a midpoint. Okay, but we still have something to fill in here and here. Okay, so we go down and list some more. Do we have a bisector? No. Do we have parallel lines? No. Do we have perpendicular lines? Yes. So if we have perpendicular lines, we have right angles. So since Rn is perpendicular to AG, we know our right angles are going to be here. So it's angle RAG. Okay, and angle NAG are right angles. What's the definition of perpendicular? Perpendicular lines are lines that intersect and form right angles. So if we have perpendicular lines, we have right angles. After that, that's not a congruent statement, so we need to go one step farther. We need to look at the right angle theorem. Okay, and the right angle theorem is going to tell us that all right angles are congruent. So now that we have right angles, we can use the right angle theorem to say that our angle RAG is congruent to angle NAG. Okay, and then we now have three congruent statements, two pair of congruent sides, one pair of congruent angles. That pair of angles is between the two sides, so we have side, angle, side. So we can then use side, angle, side to show that those two triangles are congruent. And that would be that. Perpendicular lines means we have right angles. Right angles mean the right angles are congruent by the right angles. Okay, and then we had a shared side, so we used the reflexive property. And then we had a midpoint, so we used the definition of a midpoint. Okay, and then now we have our last ones, 3 and 4. Okay, here we have two givens. Segment XY bisects angle WYZ. Okay, we also have angle WXY is congruent to angle ZXY. So let's fill that one in. WXY is this angle right here. That's congruent to angle ZXY. So let's go down our list. First one is vertical angles. We don't have any. Second one is shared sides. We do have a shared side. Okay, that is right here. So we have XY is congruent to XY. Okay, that's your reflexive property. Keep going down the list. Do we have a midpoint? No. Do we have a bisector? Yes. Okay, so it's telling us XY bisects angle. So here's our angle. Let's do a different color. Okay, we're bisecting angle WYZ. So that's the angle we're bisecting. Okay, XY is bisecting that, meaning it's cutting it in half into two equal pieces. So the two pieces are going to be angle WYX, and that's going to be congruent to angle ZY X, and that's the definition of a bisector, an angle bisector. Right, so if we have an angle, we cut it in half, we cut it into two equal pieces. That's what a bisector does, it cuts it in half. So segment XY bisects the big angle here, cutting it into two equal pieces. Okay, we now have two pair of angles and one pair of sides. So we have angle, side, angle. The side, the pair of sides is between the two pair of angles. So we have angle, side, angle. And that's going to tell us our triangles are congruent. So it's going to tell us triangle WXY is congruent to triangle ZXY. Okay. The last one here. So we have three givens. Okay. So we have angle ABC and angle EDC are right angles. We have AC is congruent to EC. And we have C as the midpoint of BD. Vertical angles, no. Shared sides, no. Midpoint, yes. So C is the midpoint of BD. So if C is the midpoint, that means BC and CD are going to be congruent. Okay, that's the definition of a midpoint. Okay, do we have a bisector? No. Do we have parallel lines? No. Do we have perpendicular lines? No. But we do have right angles. Okay. So we should have marked this too. AC was congruent to EC. Okay, and then BC and CD. Okay. So the thing here then is, since we have right angles, right? We can use the right angle theorem to say that they're congruent. So if these are our right angles. If we use the right angle theorem to say they're congruent, we then have angle side side. We can't use angle side side, so we want to try to use HL instead. Whenever you have angle side side, you're going to want to try to use hypotenuse leg. So we're going to try to use hypotenuse leg here. To use hypotenuse leg, you need three things. You need the triangles to be right triangles, you need the hypotenuses to be congruent, and you need a pair of legs to be congruent. We have the hypotenuses congruent, that was given. We have a pair of legs that are congruent, BC and CD. That was given, we got that from the definition of a midpoint, because C was the midpoint of BD. So the third thing, the thing we're missing is right triangles. But since we have right angles, we know these are right triangles, because right triangles, definition of a right triangle, tells us that right triangles are triangles with right angles. So if we have a right angle, we know triangle ABC and triangle EDC are right triangles. Okay. So these two triangles are right triangles. We now have right triangles with hypotenuses that are congruent and one pair of congruent legs. So we can use HL to show that our triangles are congruent. Triangle ABC is congruent to triangle EDC. Okay, so normally when we have right angles, we want to use the right angle theorem to say that right angles are congruent. But if we did that, we would be stuck with angle side side, which is we cannot use to show that triangles are congruent. So since we had right angles, we backtracked and we tried to use HL, hypotenuse leg. And to do that, we already had two pieces. So we had the hypotenuse congruent and one pair of legs. Then the third thing we needed was right triangles. So since we had right angles, we had right triangles. Since we have right triangles with congruent hypotenuses and one pair of legs congruent, we have triangles congruent by hypotenuse leg. And that's that.